Good evening, everyone. I hope everyone is good. Everyone is fine. So, today we are back again with the new session, and the chapter we are going to cover today is Haloalkane and Haloarenes. I hope you all know that it's a very important chapter. It is the first chapter in class 12th organic. Now, the question that comes from this chapter will be, more than what really how long this chapter is. So, basically, we can say that you can get more marks from less amount of work. So it's a very important chapter, and the question that comes from here are very good, very easy to solve. So today we'll try to solve as many type of question possible as we have got in the previous years. Okay, so without any wastage of time, we'll go further. So the chapter is Haloalkane and Haloarenes. I hope you all know that what is Haloalkane and Haloarenes. Now, this is something, if you talk about haloalkane, let's say there is any of the alkane is there. If there is any halogen is attached to it, it will be haloalkane. Now there are many types like 1 degree, 2 degree, 3 degree. I hope you all understand how do you say how to find out what is 1 degree, 2 degree. If the halogen that is attached to 1 degree carbon, it will be 1 degree, 2 degree, 2 degree, 3 degree, 3 degree. I hope you all understand it, right? So similarly, if it is at the vinylic position, vinyl. If it is at allylic position, allyl. If it is at the benzylic position, it will be benzyl. So there are lot many. There may be mono substituted haloalkanes, di-substituted, tri-substituted, or you can say poly-substituted haloalkanes. So if there is only one, let's say one halogen is substituting, it will be mono substituted. Let's say it is di-substituted. In the di-substituted also, there will be two possibilities. Let's say these halogens are like that, or there is a possibility that both the halogens are at the same carbon, right? If it is at the same carbon, it will be gem dihalides, while it will be Wick di, that is vicinal dihalides. Okay, I hope you all understand it. These are the basics of something that I hope you all understand. So now, without wasting any time, I'll go further. Now, what is the method of preparation? Basically, if you talk about the method of preparation, you will see its reaction from alcohol to haloalkanes, from alcohols to haloalkanes. What are the ways? We can just directly say from alcohols to RX, or we can go like, let's say there may be alkanes, and then alkanes to haloalkanes. There may be alkene, then alkene to haloalkane. So these are the possibilities that we can go with. How can you say? If there is alcohol, you can just make it react with PCl5 or PX5, PX3, or you can say PCl5, PCl3, or we can say phosphorus plus halogen. You may take zinc chloride plus halogen, or you may take SOCl2. SOCl2 ke saath reaction, it is called Darzen reaction. That gives the best amount, or you can say the best yield in the whole, from alcohol to alkyl halide mein. So this will give you the best yield. Is this okay? I hope so. So if you talk about alkane to this, so I hope again here it will be just substitution. We have already studied last day in the presence of H nu, sunlight and halogen. You can get this. Then alkene to HRX, it will be nothing but it's a kind of addition reaction. There are two types of addition reaction. There is one is, I hope you know about it. One is Markovnikov, another is anti-Markovnikov addition. Okay. And next, one more thing is maybe possible. See, there are lot many types of reactions. Lot many possibilities are there. So we'll directly go to that part. Now, if you talk about the reactions, which kind of reaction it shows? So generally, it shows which kind of reaction? Because if you see, halogens are what? If they leave carbon and halogen. So can you see this carbon? This bond is nothing but it's a polar bond. So can we see that their delta will be getting negative? Here it will be delta negative and here it will be delta positive. So here can we say that this is nothing but it's a kind of nucleophile. So if there is any other nucleophile is there, so what may happen? That nucleophile may substitute it. So this is nothing but it is going to give you nucleophilic substitution reaction. So what kind of reaction they are going to give? They are going to give nucleophilic substitution reaction. Now they may give nucleophilic. Now which nucleophilic substitution reaction? This may give SN1 or SN2. Now when SN1 it will give and when SN2 it will give. See, I'm telling everything in, just verbally, just for, because it's a revision class. So I am just making you remind all of these points. Now when it will go give SN1 and when it will give SN2. SN1, whenever there are, let's say, there are few conditions you have to always keep in mind. For SN1, polar solvent, while in SN2, you can say non-polar solvent is, better to go with. Now, if you talk about here it will be polar, product will be better. Now, if you talk about SN1, which kind of nucleophile is there needed? It is weak nucleophile is needed. While here in SN2, strong nucleophiles are needed. We'll see that which are strong, which are weak. How do you say something is strong? How do you say something is weak? And the most important point that you have to always keep in mind, that what is the mechanism of SN1 reaction? SN1 reaction goes through the intermediate formation. What is the intermediate that is being formed? It is cation, or you can say carbocation. So through the carbocation formation, so if you have to see the where SN1 reaction is going faster, so you always have to say that where the more stable carbocation is being formed. But if you talk about SN2 reaction takes place in only one step, while SN2 was taking place in two steps. Now, it was only depending on the substrate concentration, but it will depending on the nucleophile as well as substrate, both the concentration. Okay. Now, in SN2, the reaction is of single, or you can say one step reaction. But what is the main thing you have to keep in mind, that here when the nucleophile attacks on the substrate, what happens? That here let's say it is optically active. So what will happen? Let's say it is D, so final substance will be L. So basically what will happen? Inversion of the configuration takes place in SN2. While in SN1 what happens? Both the possibilities are there. Inversion may also be happening, retention may also be happening. So basically we say that 50% of inversion product, 50% of retention product we get here in SN1. These points you always have to keep in mind. Now SN2, what will be the main thing, or what will be the main reason for rate of reaction? It will be steric hindrance. If lesser the steric hindrance, faster the rate of reaction. More the steric hindrance, lesser the rate of reaction. Any doubt? No doubt. Now let's say there is, Rx is there. So which X will be faster rate? Wherever there will be weaker bond, it will be faster rate. So what we can say, in SN1 or SN2, if Ri, or you can say there is X belongs to iodine. So because we know that carbon iodine bond will be weakest. Why? Because we know that this is the bond length maximum, and not so good overlap, because carbon is from second period while iodine is from the fifth period. So 2p 5p is not going to be such a good overlap from there. So what we can say, so Ci bond is weakest, so it is easy to be broken. So there the rate of reaction is fastest. So Ri is more than Rbr, more than Rcl, more than Rf. Generally Rf does not give SN1 or SN2 reactions. The reason being that CF bond is strong, very very strong. I hope you all understand it. Next, let's directly come to the SN1 and SN2. What are the nucleophiles that we use? Now see, let's say if you are using NaOH, or you can say aqueous NaOH. Basically what they will tell you, aqueous NaOH. So what it will be giving? Nucleophiles will be OH minus. OH minus has the complete negative charge, so it is a strong nucleophile. If it is a strong nucleophile, so it will be generally taking place. I hope you understand. Strong nucleophile will be SN2. True, SN2. What will be the substitution product? ROH, because OH minus will come and halogen will be removed. So alcohol will be the final product. H2O H2O itself is the nucleophile. But can you say that there is no negative charge? So it is what? Weak. It is what? Weak. It is what? Strong. So it will give you SN1. What about NaOR? Here OR minus is there. That is also going to be strong. So this is going to be SN2. I hope you all understand it. NaI, I minus, strong. So what we can say, it is also going to be SN2. What about NH3? NH3, can you see, is there any charge? No. So therefore it is going to be weak. So what we can say, it is SN1 generally. RNH2, RRNH, whatever it is, all of them are going to give SN1, SN1. The reason being that all of them are weak, because there is no charge on them. What is the final product? We can see that again, one hydrogen. So यहाँ से हटाओ, वहाँ पे R लगाओ. That's it, because it is going to be attacking, and one hydrogen will be removing with the halogen. So these things I hope you all can understand. Sir, can you show the first slide? Yeah, please. First slide is nothing but this haloalkane, haloarene, where I have just explained everything. I have explained everything of the basics. You can just see this video again, right? That we can be at the faster rate, because it is very important to be faster at that time. Okay, at this time. Now there are some more are there, like KCN. KCN, always remember, if there is KCN or NaCN, and if there is AgCN. If there is AgCN, the final product will be isocyanide. If this will be isocyanide or isonitrile. If you take KCN or AgCN, it will be KCN or NaCN, it will be nitrile, that is CN. बहुत important. This is very 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 important. And but more important thing is that both of them are strong nucleophiles. Please keep in mind. Now, if you take KNO2, it will be RONO, means alkyl nitrite. इसे क्या बोलोगे? Nitrite. But if you take AgA, देखो, if you take KNO2 or NaNO2, here there will be a different product. While if you take AgNO2, it will be a different product. So if you take AgNO2, it will be a nitroalkane. So here the product, here the bond will be formed through the nitrogen, while here the bond will be formed through the oxygen. So it will be alkyl nitrite. Okay. Now RCOAG, LiLH4, all these things are there. I hope all these things you can see wherever there is metal. So metal will always get the positive, the remaining part will be negative. So here hydrogen will take as the hydride. Here if let's say R minus means organometallic substance is there, consider if there is organometallic substance is there, always R minus, that will make this R minus will attack, RR dash will be formed. Here H minus will attack, RH will be formed. Here RCOAG will be giving RCO minus, that will be RCOR will be, that is ester, alkane. These things I hope you all can see, and you can just take a screenshot. Now again, now directly we'll come to the question solving. Chalo bhai, shuru karte hain. IUPAC name of the allyl chloride. What is allylic? Allylic. Can you see? This is the allyl part. Now इसमें क्या लगा दो? Chloride. Can you see? Is there any functional group? Yes. Functional group कहाँ पे? Double bond. So for that, you should give the minimum number 1, 2, 3. So where chlorine is there at the third position? So it will be 3 chloro. How many carbons are there? 3. So 3 chloro, 1 propene. So what is that? 3 chloro, 1 propene. Any doubt? I think there is no issue. Isomerism shown by 2,3-dichlorobutane. Just can you make that 2,3-dichlorobutane? Now Cl, Cl. Can you make Cl here? And can you make Cl here? 2,3-dichlorobutane. Okay. Hydrogen is there. Hydrogen is there. Can you see that this is nothing but this is optically active or chiral? There is methyl, hydrogen, Cl, and the whole part is there. So what we can say, this is optically active, and this is also what? Optically active. So if it is optically active, so what will they show? They will show optical isomerism. Now C2H5OH plus SOCl2. It is nothing but, I told you, whenever alcohol is going to be giving, alcohol gives the reaction with the reaction of PCl5, PCl3, phosphorus plus halogen, and SOCl2, and zinc chloride and halogen. These things are there, right? But here what is given? C2H5 plus SOCl2. इसे क्या बोलते हो? Darson reaction. Darson reaction gives the best yield of the, you can say that RCl. So here what will be the formation? Directly I am giving you. Why does it give the best yield or maximum amount of product? The reason is remaining whatever is the byproducts are there, they are gaseous. So if they are gaseous, they will leave the whole reaction mixture, and remaining part will be pure alkyl halide. So what are the things that will be formed here? Consider there is ROH is there. Whenever ROH reacts with SO2Cl, it is going to give you RCl plus SO2 plus HCl. HCl will be gone, SO2 will be gone. What will be there? RCl will be there. So here R is nothing but C2H5. So what will be there? C2H5Cl plus SO2 plus HCl. Is there any issue? No issues. So it is called Darson reaction. Darson's reaction, and gives best yield of alkyl halide. Reason is because byproducts are gaseous. Okay. Alex sir is not coming today. He is coming on 27th. So please, you can hold your all that happiness for Sunday. Okay. Now you can just study here. CH2 C double bond CH NO2 HBr giving P. The major product of this reaction will be. Please, students, I would suggest you whatever is the extra questions are there. Please post me in the chat box later on after completion of my this session. Once the session is completed, there you can put the questions through the timestamp. I will answer you later on also if you have any question. Now there is this question, HBr is reacting with this, the major product it is asking for. Always, now here you can see like that whenever such kind of questions are there, always try to think if there is pi bond is there, so pi bond will be broken and HBr is going to be added. because there is what double bond. So alkene will show the addition reaction. अगर addition reaction होगा तो सोचो जरा कैसे होगा. So there is going to be polarization of the pi bond. अगर polarization of the pi bond होगा वो इधर, where there is more positive, more stable positive charge, you always have to think about it. क्या यहाँ पे ज्यादा stable positive बनेगा या फिर यहाँ पे ज्यादा stable positive बनेगा? जरा सोचो. Because NO2 is what? It is nothing but it is minus M effect or minus I effect. That too very strong. Minus M and minus I. So will it stabilize positive charge? No, it will destabilize positive charge. So this positive should not be here. Means this pi bond will be something like that. इसे minus, इसे plus बना दो. अब इसे H plus और Br minus break कर दो. Just think about it. This negative will go for the positive and this positive will come for the negative. So what will be the product? CH2Br CH2NO2. Okay. So option is, I hope A is very clear answer. Any doubt? No doubt. Which of the following is correct for the reaction? For this reaction, HBr plus peroxide. So what it wants to say? It wants to show Kharash effect. Kharash effect. Also called peroxide effect. Peroxide effect. Peroxide effect only works on HBr. Only works on HBr, not on HCl, not on HI. HI और HCl पे नहीं काम करता है, only on HBr. Is there HBr? Yes. Is there peroxide? Yes. So what happens? This is nothing but it tells you that other than Markovnikov, there anti-Markovnikov addition will take place. अगर anti-Markovnikov addition होगा, तो Markovnikov says that the negative part of the addendum goes to that part of carbon where there is less number of hydrogen, or you can say more substituted carbon. But go with that rule. कि Markovnikov says that negative part, that is minus plus, so negative part will go to that carbon where there is less number of hydrogen, but the anti-Markovnikov rule be just going opposite, means it will come to here. So what we can say? CH3. So hydrogen will come where? Here. CH3, CH2, CH2Br. Why does this happen? This happens because of the whole reaction starts going through the free radical mechanism. Please go through the mechanism because the lack of time we cannot go to the mechanism, but still remembering things are very important, that how this whole things are working. I hope you all are understanding these parts. Okay, चलिए आइए तो देखिए भाई, is there any, अच्छा, what is that? Okay, it is asking for what is that addition? It is anti-Markovnikov addition. Okay, चलो आगे. RCl plus NaI giving Ri plus NaCl. इस रिएक्शन क्या बोलते हो? It is iodination. Iodination के लिए this reaction is used. इसे बोलते हो Finkelstein. Finkelstein reaction. Finkelstein में क्या होता है? Iodination होता है. RCl, you take any of the RX and you make it react with NaI in the presence of acetone. What it will convert into Ri. Okay, is there any दिक्कत? No दिक्कत. So क्या ये बात समझ में आ रही है कि ये क्या है? Finkelstein reaction. So option C is the correct option. Next आगे बढ़ो. Which of the following is an example of vicinal dihalide? I have already told you when you say vicinal, when you say geminal. Okay, so can you see dichloromethane, methane, Cl. Can you see that it is nothing but both the chlorine at the same carbon? It will be geminal, not vicinal. No, it will be gem. 1,2 dichloroethane. Can you see Cl at 1 and 2 position? 1 and 2 position. Can you see that both the chlorine are at the different or we can say adjacent carbon? So what we can say? This is yes for sure. This is called vicinal. Not a big deal. Option B is the correct option. Okay. I hope so. It is very easy. Chaliye. 3-methyl pentoene on reaction with HBr in presence of peroxide form and addition product. The number of the number of possible stereoisomers for the product. देखो पहले तो आप रिएक्शन करा लो कि 3-methyl pentoene now 3-methyl pentoene, this is the substrate. अब इस पर रिएक्शन किसका करा रहे हो? HBr in the presence of peroxide. If it is peroxide here, what will happen? I hope you all understand. यहाँ पे anti-Markovnikov addition होने वाला है. What will happen? Anti-Markovnikov addition. If anti-Markovnikov addition is there, so what is the rule? That the negative part of the addendum, that is here Br minus. So this will go to that carbon where there is more number of hydrogen. That is where, while For Marconi coop it will go to that carbon where there is less number of hydrogen. तो जरा सोचो कि इन दोनों pi bond में कहाँ पे less number of hydrogen, यहाँ पे 1, यहाँ पे 0. So where the bromine will come? It will come to that part where there is more number of hydrogen. So आ जाओ जरा, what will be the product? It will be something like that. Here it comes Br, here it comes Me. Double bond broken. Okay, yes or no? So here H plus will come here. Not a big deal. चलो ये अपना हो गया product. Can you think about this product? Now the number of possible isomers. Now just think about it. कि is it optically active or can it show geometrical isomerism? No. Can it show optical isomerism? We'll have to check. What we have to check? We have to check that whether there is any chiral carbon is there. Yes, there is a chiral carbon because all the different elements are, or all the different groups are there. So there is one chiral carbon. Is this also chiral carbon? Yes, it is also, because there is all different groups are there. Can you see? Because all the different groups are there, so this is also chiral. So how many chiral carbons are there? 2. Is there any kind of symmetry? No. If there is no symmetry, directly formula is 2 to the power 2. That is how much? 4. 4 different possible stereoisomers or stereo products will be formed. The synthesis of the alkyl fluorides is best accomplished by, just think about it. What is that formula? I hope you all know about it. Swartz reaction. Swartz reaction. Finkelstein for iodination. Swartz reaction for fluorination. Fluorination. What is the reaction? That Swartz reaction is nothing but, just see that, Swartz reaction. Swartz reaction, something like that. If you take alkyl halide and make it react with, देखो अब यहाँ पर बहुत जरूरी है कि ये समझो कि इसका रिएक्शन किससे कराओगे. You will have to make it react with silver fluoride or cobalt fluoride or SbF3, or you can say. So these are the few of these things that will be used. So these things when you use, what happens? So you get the heat, then it will form RF plus AgX. But that thing is not so important. So RF, formation of RF through the Swartz reaction. So this is the whole product. So Swartz reaction is the main reaction for fluorination. चलो आगे बढ़ो. The reaction condition leading to the best yield of C2H5Cl. क्योंकि देखो अब आप सोचोगे सर क्लोरीनेशन ब्रोमिनेशन को हम लोग with the help of HNu and chlorine or HNu of in the presence of sunlight we do. Why don't we do with the fluorination and why don't we do iodination there only? No, because when we do the fluorination, I have already told you yesterday when we were studying about hydrocarbon that the reaction is very highly exothermic and there is a possibility of accident. But if you talk about iodine reacts so slow that what happens in such a case? In such case, and anyways the reaction is slow and anyways Hi as the product is formed. Hi being a good reducing agent, it makes the reaction reversible, you can say, in the backward direction. So the product whatever you have to get, the yield becomes very less. That's why iodination and fluorination are not good way to get through in the presence of HNu and halogen. Okay, next, the reaction condition leading to the best yield of C2H5Cl, which is, I hope you all can see that how much of chlorine is there? Monochloro product. It is what? Monochloro product is there. So if it is monochloro product, so always remember that chlorine should not be excess but alkane should be in excess in the presence of HNO. So option A is correct. But what if you take Cl2 in excess? It will be just a minute. No, यहाँ पर तो ऐसे भाई dark room temperature की बात कर रही है. No, इससे की बात ही नहीं करो. Here Cl2 in excess is there. So what will happen? C2H5. It will be here polychlorination will take place. Polychlorination will take place. So because the whole reaction was stepwise, chain reaction. So one after another, it will keep on making more and more chlorination. So here polychlorination will take place. But we want monochlorination. In such case, this is taken in excess and chlorine is taken as the limiting reagent. Next, when hydrochloric acid gas is treated with propene in the presence of benzoyl peroxide. Benzoyl peroxide means it wants to tell you about the peroxide effect. But does the peroxide effect work on HCl? No. Peroxide effect only works with HBr, not with HCl. So therefore what we can say here, directly just do that. Propene, just a minute. Treated with propene. अगर HCl से reaction होगा, directly यहाँ पे क्या करोगे? Marconi coop addition करा दो. Means you have to put negative part of the addendum to that part of the carbon जहां पे नंबर ऑफ हाइड्रोजन इज लेस, यहाँ पे कितना हाइड्रोजन है 2, यहाँ पे कितना हाइड्रोजन है 1, so Cl minus will go here while H plus will come here, so what will happen, it will be something looking like this, so it will be 2-chloropropane. Option A is the correct option. Next, the compound that reacts faster with Lucas reagent, Lucas reagent के साथ faster in the concentrated HCl and zinc chloride at room temperature. Lucas reagent में it is used for, you know, identification of 3 degree, 2 degree and 1 degree of the alcohol. For, so what happens, 3 degree gives faster, reacts faster and turbidity just at that time only, very quick, very fast, immediate, while 2 degree not so faster, we can say moderate rate of reaction, and it will be turbidity after 5 minutes, turbidity after 5 minutes. But if you take 1 degree alcohol, it is all alcohol, it is alcohol, 1 degree alcohol is there, then it does not give turbidity, but it can give turbidity at higher temperature, turbidity, so it is very slow first of all, and turbidity after hours in at high temperature, at elevated temperature, at high temperature. Okay, so these things you can just keep in mind. यहाँ पर जो reaction होता है generally it is SN1, here it is SN2 as well as SN1, both of the products. Here it is completely SN2 product is there. Any doubt? So here what is there? So whichever will be 3 degree, it will give the fastest, react fastest, means 3 degree will be fastest. So can you see butane 1-ol? Butane 1-ol means 1, 2, 3, 4 OH. Butane 1-ol, no, it is what? 1 degree. 1 degree, very slow. Butane 2-ol, very slow, because it is also what? It is 2 degree. Here 2-methylpropane 1-ol, 2-methylpropane 1-ol. Can you see? Here, no, it is also not. 2-methylpropane 2-ol, 2-methylpropane 2-ol. Can you see? It is what? 3 degree. So option D is the correct option. Next, the product of the reaction. For this reaction, what we have to see, can you see there is going to be oxygen. Oxygen is there, H plus is there. Can you see oxygen is what? It is a nucleophile having the lone pair. So what will happen? It will attract this, and because we know that there is heat also, means it wants to go through the, it wants to, you know that whenever there is alcohol is there in the presence of acid and heat, it gives elimination. What will happen? Elimination reaction. How this elimination reaction is going to take place? Zara dhyan se dekho bhai. What will happen here? H plus OH minus will be attacking on this H plus. What will happen? It will convert into, can you see? देखो पूरा पार्ट आपको करना पड़ेगा. You have to just do that. OH2 plus. Now what will happen? Because we know that oxygen pe positive is not so good thing. What will happen? This will give the lone pair. Basically, this whatever is the bond pair, it will be taken by oxygen. What will happen here? It will be something looking like this. Here positive charge. What will happen? There is 5-membered carbon ring, and 5-membered carbon ring can expand. यहाँ पे क्या हो रहा है? There is going to be ring expansion. Why ring expansion takes place? Ring expansion is a way of carbocation rearrangement. Carbocation rearrangement is there. So what will happen? It will be something looking like this, you know. And then we are going to have this whole part. Can you see how many membered ring is now there? We have 6-membered ring. What is that? It is nothing but it is 6-membered ring. If there is 6-membered ring and there is the positive charge is at 3 degree carbon, it is at 3 degree carbon. So what will happen? Because we have this, now what we have, heat is there. Once the heat is there, what will happen? Just think about it. Always think in that way. There is going to be elimination. So which kind of elimination is going to take place here? E2 elimination. Now what kind of this? Can you see beta hydrogen? Can you see beta hydrogen? Of course beta hydrogen you would be seeing. So how many of the beta hydrogens is there? 1, 2, 3. So these two are similar hydrogen, but this is what? This is a different hydrogen. So there may be a possibility of two products. One though is this and another is through this. So there are two parts. Can you see which is more stable? You can see that it is Sadzev product. It is Sadzev product. Sadzev, but it is what? Hoffman product. See, I would not be, so see, just you can see that which is having more number of alpha hydrogen. Can you see how many of the alpha hydrogen is there? 1, 2. How many are there? 3. And how many are there? 2. So how many of the total alpha hydrogens are there? 7 alpha hydrogens are there. So it is more stable. But what about this? Only 4 alpha hydrogen is there. 2 here, 2 here. So what we can say, which is more stable? I think you all can see that this is more stable. So which option will be correct? Option C is the correct option. A very good question. It is asking for the X. So basically it is asking for the major product because it has not given two options. Which of the following products is not possible in the above reaction? Can you see here it is HI. So what will happen? Again see that H plus OH minus. So what will happen? First of all, H plus I minus, just make it attack here. What will happen next? Next will be something like that. What will happen? Here OH2, it will take OH2. Then what will happen? This lone pair will be taken by water. This bond pair will be taken by H2O because oxygen has got positive charge. What will happen in such a case? Oxygen H2O will be removed. H2O will be removed. And what will be here? There will be just positive charge at the 2-degree carbon. So here, is there any possibility of ring expansion or more stable product? Can you see what is there? There are 3 alpha hydrogen here and 1 alpha hydrogen here. So 4 alpha hydrogen is there. So it is very stable. See, always remember, if there is a possibility of ring expansion, always do the ring expansion. Ring expansion kara do bhai. Ring expansion kara karke dekho. What will be the final thing? That will be formation. It will be something like this. Can you see? We can see something like that. How many total number of carbon are there in the whole ring? 1, 2, 3, 4, 5, 6. So make it 6-membered carbon ring, positive, and there is what? This. Now what we can see here, there is I minus. H plus is there, I minus will also be there. So I minus will attack here, and what will be the final product? That will be formation ICH3. So is there any option like that? Yes, option D is the correct option. Any doubt? No. आगे बढ़ो. The product A is of the above reaction. In this above reaction, SOCl2 pyridine. SOCl2 pyridine reaction मतलब it is going to have Darzen reaction. चलो भाई जरा ध्यान से देखो. OH को क्या कर देगा? Cl बना देगा. So therefore, and SO2 plus HCl. So and there is not going to be any reaction with OCH3 part. So is there any reaction, any of such kind of product where CH2Cl OCH3? Option B is the correct option. Any doubt? आगे बढ़ो. Now the major product in the following conversions. Here OCH3, this CH2 double bond CH2 CH3, HBr excess plus heat. In such case what you have to see again. क्या यहाँ पे कोई भी कुछ और दिया है क्या? नहीं भाई, बहुत सिंपल सी बात है कि there is not given anything like peroxide effect. Peroxide effect नहीं है मतलब डायरेक्टली करो. सोचो पॉजिटिव कहाँ पे ज्यादा स्टेबल है? One is more stable here or here more stable. I hope you all can see that it is going to be more stable because it is what? Benzylic position. It is what? Benzylic position. And benzylic position pe what happens? The positive charge will be resonance stabilized. Resonance stabilized. So what will happen in such a case? In such a case, I hope you all can see that negative part will come here. अगर negative part यहाँ पे आएगा तो H plus और Br minus में break करो. What will be there? Of course, Br minus will be going here. H plus will be coming here. So जरा खुद से सोचो what will be the final product. And anyways, we all have one more reason. The reason is OCH3 is there. That is what? Plus M effect. And plus M effect will stabilize this positive charge even more. Yes or no? This will stabilize this positive charge even more. So in such case, what will be the final product? The Br will be formed here CH2 CH3. So allylic position पे Br CH2 CH3. Option A is the correct option. Not a big deal, easy one. The reaction of SOCl2 in an alcohols to form alkyl chloride gives good yield because, I hope we have already seen the answer, because the other products reaction are gaseous and that escapes out. Next, in Huns-Dekker reaction, number of carbon atom decreases. What is Huns-Dekker reaction? Consider करो जैसे कि RCOO Ag is there. When it reacts with C, I am taking it in fast forward. We know that there is whole reaction is a very important, very beautiful reaction is there. So what happens ultimately? I am directly telling you. You have to make this RCl. You have to form RCl plus what you have to do? Plus CO2 plus you have to do AgX or AgBr, whatever is there. So or RBr. So this is something that happens. So in such case, what we can say? Can we not say that here how many number of carbon were there? R, let's say whatever is the number of carbon plus 1. So let's say this is R was having some X carbon plus 1. So here how many carbons are there? Only X carbons. So number of carbons are decreasing here. So atom of carbons decrease. Any dikkat? I hope no. Methyl butane on reaction with bromine in the presence of sunlight gives methyl butane. Just try to make this methyl butane. Okay, chalo. Methyl, because all the places are same only. On reaction with Br2 in presence of H nu in sunlight gives mainly. Acha, zara socho. Always try to think in this term. Always remember in this way. Whenever there is halogenation is going to take place, first of all I am going to do Br2 bromination, and then I am going to do chlorination. I will give you very important, thing to know. I hope all of you know, but still let me remind you these things. So if there is bromination, always remember 3 degree product is more than 2 degree product is 1 degree. As a rule, always 3 degree. If there is 3 degree carbon present, always it will be brominated. Can you see, is there any 3 degree hydrogen? Yes. Is there 2 degree hydrogen? Yes. Is there 1 degree hydrogen? Yes. So but it will always take this hydrogen to be replaced or substituted. So there it will be MEBr, always, without any doubt. So this will be the major product in bromination. But what about chlorination? In chlorination, you have to see two things. What are the two things? One, you have to see that what is the number of, you have to see that 1 degree is to 2 degree is to 3 degree, which is going to be more. So इसमें बहुत simple सी बात है. You have to see number of 1 degree hydrogen multiplied by rate of 1 degree hydrogen के लिए जो halogenation होता है is to number of 2 degree into R 2 degree. जो आपके rate of 2 degree halogenation के लिए होता है. Next, number of 3 degree carbon multiplied by rate of 3 degree. अब जरा सोचो ये क्या है, R1 R2 R3 का क्या वैल्यू होती है? प्लीज कीप इन माइंड R1 is to R2 is to R3 is nothing but 1 is to, sorry, here we have 3.8, and basically here how many carbons are there and which kind of carbons are there? We have 2 degree here, 1 degree here, and here we have 3 degree, and here we have 1 degree. It is what? 1 degree. And how many are there? 3. So 3 into 1 degree, but it is a different type of, let's say it is A type, let's say it is B type. So it is also 1 degree, but it is different from this. So both of them, okay, just a minute. We have same, because here also we have methyl, 1, 2, 3, hydrogen, hydrogen, hydrogen. Can we see it is also A type? It is also A type. So here we have, okay, we have 3, 3, 6. Here we have 3 and 3, 6. And here we have how many of the 2 degree are there? 2 degree hydrogens are there. We have 2. And how many 3 degree hydrogens are there? We have 3 degrees. How many of 1 degree is there? 1 degree. But it is B type. It is A type. Consider करो इसे C type. It is what? D type. अब इसमें जो almost it is the number 1 is to 3.8 is to 5.2. It is the ratio of rate. 1 degree is to 2 degree is to 3 degree. So what will happen? How much of the 1 degree hydrogens are there? 3, 3, 6. So it will be 6 ones are 6. What about this 2 degree? It will be 2 into 3.8. It will be giving you 7.4. How many of the R3 is there? So it is how many? 3 degrees how much? 1. 3 degrees how many? 1. 1 into 5.2 will give you 5.2. Which is the biggest number? Biggest number, I hope you can see that, 7.4. So here the major product will be from the 2 degree hydrogen ka substitution. So 2 degree will be more, while here it will always in bromination it will be 3 degree. Always remember bromination is more selective and less reactive. But chlorination opposite. I'm writing opposite. Understand it. What I mean to say, opposite matlab more, less selective, more reactive. Okay. So these things are there. So which is the most major product in bromination? Always 3 degrees more than 2 degrees more than 1 degree. Okay. Because 3 degree hydrogen was there. So of course 3 degree. So option is going to be 2 bromo 2 methyl, 2 bromo 2 methyl. butane. Option B. Next, the increasing order of reactivity of the following halides in the SN1 reaction. Always remember, as I told you, for SN1, what is the main factor? Stability of carbocation. For SN2, what is the major factor? It is the steric hindrance. Steric hindrance. I hope you all understand it. तो आ जाओ जरा देखो, अब कहाँ पे आपका Cl को हटाने के बाद ज्यादा स्टेबल कार्बोकेटायन बन रहा है. अगर Cl हटेगा, so this will be a what? It will be 2 degree. It will be a 2 degree कार्बोकेटायन. What it will be? It will be a 1 degree. अच्छा यहाँ पे बताओ जरा, what will happen? It will be पॉजिटिव. अब आप बोलोगे सर इट इज 1 डिग्री कार्बोकेटायन. अरे नहीं नहीं नहीं, 1 डिग्री कार्बोकेटायन मत देखो. चेक दैट. इट इज व्हाट? इट इज बेंजाइलिक पोजीशन. इट इज व्हाट? इट इज बेंजाइलिक पोजीशन, एंड दैट टू हियर OCH3 is there. OCH3 will be plus M effect, and due to this plus M effect, this positive charge will be highly stabilized. Stabilized due to what? It is stabilized due to resonance. Due to resonance, because this is benzylic position. So maximum will be for this. Then after that will be, always remember कि 3 degree is more than 2 degree is more than 1 degree. But if it comes benzylic, तो benzylic को आप 3 degree के ऊपर भी दोगे. Benzylic position will be even more than 3 degree, or more than or equal to in some cases, but you have to take this one only here because it is plus M effect is there. So what we can say, 3 is more than 2 is more than 1. 3 is more than 1 is more than 2, because here it is 2 degree, here it is what? 1 degree. 2 degree is more than 1 degree. Here it is 1 degree carbocation, here it is 2 degree. So 3 1 2 3 1 2. 3 is more than 1 is more than 2. Option B. Next is, which of the following potential energy diagram represent the SN1 reaction? Always remember, SN1 reaction is a two-step process. In two-step process, what happens? Carbocation intermediate form. अगर carbocation intermediate form होता है, तो what will happen? First of all, the first intermediate that is going to be formed, it will take of higher energy, and then it will be something like that. तो समझो कि पहले में क्या हुआ? There will be, the whole reaction something goes like that. How does it happen? Consider Rx is there. Consider CH3, X is there. So first of all, what will happen? There will be CX bond will be broken in the presence of what? Consider करो, जो भी आपका polar protic solvent है, polar protic solvent में क्या होगा? Break होगा. Then there will be CH3 plus. So it is what? Carbocation formation. So first step is carbocation, that is highly endothermic. Okay. So what will happen? This will be of higher energy. It is of higher energy. And उसके बाद क्या होगा? There will be a part where there will be a intermediate formation. Intermediate is nothing but carbocation. उसके बाद क्या होगा? There will be another. Then there will be attack of X minus. X minus will be attacked from any side, right? So once the X minus will be attacked, so it will be a second reaction, but it will have not as much reaction as the first reaction. So ultimately it will the final product. So here यहाँ पे क्या हुआ है? Carbocation formation. So option B is the correct option. But if it was SN2 reaction, for SN2 reaction, it is like that. SN2 reaction, it is like that. Why so? Because it is what? One step. It is what? One step. Okay, no doubt. आगे बढ़ो. क्या 1 degree, SN1 always is like that? No. If let's say carbocation rearrangement is there, these steps even may increase. Please keep in mind, you may work with such kind of question even more, but this is the generally such kind of question will be coming. The order of reactivity of the following alkyl halide for a SN2 reaction is, देखो पहले मैंने बताया था, जहां पे बॉन्ड इजीली ब्रेक हो जाए वहां पे सबसे फास्ट, तो RI will be fastest. So B, D, A ना, RBR, R, ठीक है. Next, SN2 reaction, the correct order of reactivity for the following compound. अच्छा, SN2 के लिए क्या देखना होता है? SN2 के लिए steric hindrance. So always remember, methyl halide is more than 1 degree, more than 2 degree, more than 3 degree. 3 degree SN2 देता ही नहीं है, जैसे कि 1 degree SN1 नहीं देता. 3 degree does not give SN2. Always remember. Can you see methyl? Yes, methyl के बाद it is 2 degree. No. It is 1 degree. 2 degree can never be more than 1 degree. Wrong है. Here it is methyl. Of course more. It is 1 degree. It is what? 2 degree. It is what? 3 degree. So of course B is the correct option. Any doubt? No doubt. आगे बढ़ो. Which of the statement is true for the above reaction? चलो इस reaction को जरा ध्यान से देखो. What is happening? See this is there. Can you see it is 2 degree. NaOH के साथ reaction हुआ है. तो NaOH क्या देता है? OH minus. It is a strong nucleophile. Strong nucleophile gives SN2 or SN1. SN2 generally because 2 degree may give you SN1 as well as SN2. SN1 as well as SN2. पर किसकी बेसिस पे डिपेंड करेगा? फिर न्यूक्लियोफाइल. इफ न्यूक्लियोफाइल इज स्ट्रॉन्गर इट विल गो फॉर SN2. इफ न्यूक्लियोफाइल इज वीकर इट विल गो फॉर SN1. क्या ये बात समझ में आ रही है? जब भी 2 डिग्री है, देखो 1 डिग्री तो ऑलवेज गिव SN2. If 3 degree is there, always give SN1. If 2 degree is there, it will depend on whatever the solvent you have used and whatever is the nucleophile you are using. Here nucleophile is strong, so it will go through SN2. SN2 में क्या होता है? I hope you all have studied and I have today also only told you about it. Inversion takes place. क्या यहाँ पे inversion हो रहा है? हाँ भाई, देखो iodine इधर से था because OH minus is going to attack from back side. So therefore the whole product is inverted. So this is, if it was D, it will become L. If it was L, it will become D. I hope you understand it. Now, so retention or inversion, it is inversion of configuration. How? Now the reaction, this is described as, I hope you can see that there is also inversion of the configuration. So this is what? SN2. अरे थोड़ा ऊपर नीचे हो गया. I hope you understand it. SN2. Next, when CH3, CH2, CH, Cl2 is treated with NaNH2, the product formed is, always remember NaNH2 being a strong base with heat. What it gives you? It gives you elimination reaction. Elimination reaction. अब elimination reaction कैसे होगा? There will be two times of, and that to how many times? 2 times elimination it may take place. So how many of the hydrogen is there? Beta hydrogen. You can see this is what? Alpha carbon. This is what? Beta carbon. So alpha beta elimination 2 times. So how many bonds will come? 2 times. 2 times 2 of HCl will be removed. What will be there? There will be CCH, 1 hydrogen, 1 double bond, 2 hydrogen, 2 chlorine. So one more pi bond. So what will be happening? There will be triple bond will be there. That is, third option is correct. But okay, if there was alcoholic KOH was given, or alcoholic KOH was given, so always remember you will not go for 2 times of elimination. You will do only 1 type of elimination. Keep in mind. आगे बढ़ो. Reactivity order of the halides for the dehydrohalogenation is, देखो यार, dehydrohalogenation में भी जहां पे bond easily break होगा वहां पे fast होगा. तो जहां पर RI will be faster, RI, RBr, RCl, RF. क्या ये बात एकदम समझ में आ रही है? Is that okay or not? And anyways, this reaction is, E2 reaction, and in the E2 elimination we have to understand that this is going to be like that. Now 2-bromopentane is heated with potassium ethoxide in ethanol. The major product obtained is 2-bromopentane. 2-bromopentane when reacts with potassium ethoxide, potassium KOET, okay, in ethanol, ethanol. अरे ये KOET का मतलब कुछ नहीं हुआ. Again I told you ना, alcoholic KOH, alcoholic KOH, ठीक है. ये भी क्या करेगा? Elimination. What will happen? Elimination. Now you will say why it is elimination? क्योंकि याद रखना कि यहाँ पर जो आपका attacking जो भी nucleophile it is larger in size, so larger in size होने पे it acts as a better base than better nucleophile. So rather than going through substitution, it starts going through elimination. Okay, now potassium ethoxide in ethanol, the major product obtained is, अब यहाँ पे जरा देखो what are the beta hydrogens are there? Beta, one is this, so there are 2 possibilities of the product will be there. Either this will be removed or this will be removed. चलो एक बार करके देखो. चलो एक बार इसे देखो. यहाँ से मान लो ये हाइड्रोजन and this, so there is one possibility this and there is one possibility this. दूसरा प्रोडक्ट बना करके देखो. So there is another possibility this. So which is more stable? Can you see? You can see that here there is only 2 alpha hydrogen, but here there are 5 alpha hydrogen. That is major because it is more stable. So I hope you all can see that. यहाँ पर हमेशा याद रखना कि in such kind of wherever there is going to be E2 elimination, there is going to be more stable product is going to be more, or you can say major product. As you can see, so it is what 1 2. So 2 trans 2. अब इसमें भी सोचो, अब there are two possibilities, either it may be trans like this, or it may be cis like this, you know, like this. So this is what cis. So there may be cis or trans. अब बताओ जरा, cis में क्या होगा? There will be steric hindrance, but trans में there will be very less steric hindrance because they are farther, they are closer. So because of that, cis becomes less and trans becomes more. So of course, trans 2-pentene is better, not cis pentene 2. No. Next. Now we are going to study about haloarenes. Now see, haloarenes, how do you form haloarenes? Haloarenes को formation के लिए बड़ा simple सा तरीका है. I hope you all know that. So you have to do what? Halogenation. Halogenation कैसे करोगे? Halogen plus Fex3. Fex3 के साथ react करा दो, फिर क्या हो जाएगा? I hope you all know that. Here halogenation takes place. How does it take place? पूरा का पूरा reaction we know that what happens? Electrophilic substitution reaction takes place. In the electrophilic substitution, we have to make the one of the electrophile because the whole ring is nothing but there is electron density is there, pi electron density is there. So what will happen here? X plus Fex4 minus plus X plus, and then X plus will be attacking here, and this will form and H plus will be removed, and this will be formed. देखो ये तो अपना simple तरीका हो गया. There are some other few also the methods are there. We'll see that. Like जैसे कि हमें पता है, I hope you all know about Sand-Meyer reaction. Sand-Meyer reaction में I hope you all know about it. First of all, you have to do what? NH2 को what you have to do? HNO2, या फिर आप बोल सकते हो NaNO2 plus HCl at 0 to 5 degree Celsius. ये करते हो और इसके बाद ये क्या हो जाता है? डाइओजोनियम सॉल्ट में कन्वर्ट हो जाता है. It converts into diazonium salt. Once it converts into diazonium salt, you will make it react with Cu2Cl2. Once you make it react with Cu2Cl2, what will formation? There will be Cl plus, or you can say Cu2X2. Cu2X2. So here it will be halogen. Plus क्या हो जाएगा? It will be nothing but what to say? Plus nitrogen gas will be plus, you know, these things HX will be formed. So here this is something that you have to keep in mind. This is what Sand-Meyer reaction. It is what Sand-Meyer reaction. Yes or no? I hope. इसी को Gattermann reaction कब बोलोगे? When you make copper plus HX. Let's say HCl is there. So in such case, what will be there? So also the formation of the same product will be there. But in such case, what will happening? Better Sand-Meyer is understood other than Gattermann. So it is called Gattermann's reaction. Okay. So this is something I hope you all understand how it is going to work. See, अब यहाँ पे अगर फ्लोरिनेशन कराना है तो तुम्हें क्या करना होता है? NaBF4 के साथ रिएक्ट करना होता है. अगर वहीं अगर आयोडिनेशन करना है तो Ki और NaI के साथ रिएक्शन करना होता है. तो what it will be formed? It will be forming iodine. It will be forming fluorine. So these are the method of preparation. There are lot many other ways that you can do, but here these are one of the important ones that I need to tell you. Next ones like reactions. If you talk about the which kind of reaction they are going to do, they are going to give electrophilic substitution reaction as well as in very rigorous, in very different kind of condition, they may also give nucleophilic substitution reaction. But these reaction will be like Dow's method is there. There are a lot many different things are there. The mechanism is not important, but yeah, once the question comes, we'll see that and we'll solve those. Okay. Anyways, we have studied about the electrophilic substitution reaction last day also when we were studying about hydrocarbons. Chalo, now we are going to talk about this question. C6H5N2Cl, Cu2Cl2 plus HCl. This reaction is named as, for which of the following above reaction will be fastest? अब जरा खुद से सोचो. I think हम लोगों ने इसके लिए देखा है Sand-Meyer. This is Sand-Meyer reaction. ठीक है. इसमें क्या बन जाता है? C6H5Cl will be formed. Okay, आगे बढ़ो. Next, properties of haloalkane and melting and boiling point. Please keep in mind, very important question आते हैं यहाँ से, इसलिए I have taken this part. See, whenever you talk about boiling point depends on the, I have last day only told you, boiling points is directly proportional to molar mass, because it is directly proportional to, boiling point is directly proportional to van der Waals forces, that is directly proportional to molar mass. So therefore, what we know, C6H5I will be more than C6, or you can say PHBr will be more than PHCl will be more than PHF. PHF. I hope it is all making sense. Why? Because here molar mass is more. It is all okay. But what about melting point? Always remember, in melting point you have to see two things. One is, because once it is going to melt, so just think about it. Or melting point means it is already solid. Now you are trying to melt it, or you are trying to make it liquid. When there is solid, so they are there in the, you can say that they are in the crystalline form. You can consider it. Now if they are in the crystalline form, the more the what to say, packing efficiency, better packing efficiency will be there, the better they can be with together. So here what happens, the more the symmetrical, or the more the symmetry will be there, the better packing efficiency or better packing fraction will be there. So always remember, in such case what happens, if you talk about melting point, so para becomes more. Why para is more? Just think about it. Just think about it. Let's say 2Cl is there. Can you see there is center of symmetry is also there, plane of symmetry is also there. So these things are there. Due to this, it is very, very, it is very much. Now just talk about orthodichlorome. Orthodichlorome, you will see that, and you will say that, sir, there is plane of symmetry. Okay, yes, as well as one more thing is there. What is there? कि इनके बीच का कितना है mu? What is that angle? Angle is 60 degree. So can you see that 1, 2? So what is this? It is polarity. So here it is more polar, more polar, more polar. You will see. Next one is, let's say there is meta. So 1Cl here, 1Cl here. So 1Cl here, 1Cl here. Can you see? One is in this side mu, one mu is in this side. So what is the angle? Angle is how much? It is 120 degrees. 120 degrees. So mu resultant will be less. Mu resultant will be less here. Here mu resultant will be or more. So what we can say? Here it is less polar. Of course, there is also center of symmetry. Plane of symmetry is there. Here also plane of symmetry is there. So symmetry to same ho gaya, but here it is less polar. Here it is more polar. If it is more polar, so what will happen? Van der Waals forces will be stronger. If it is less polar, van der Waals forces will be weaker. Because we know that van der Waals forces are directly proportional to polar character. Yes. So therefore, iski melting point will be least, iska melting point will be second, and para will be maximum. The reason is what? Here it is, the reason is symmetry. Due to symmetry, what will happen? Iska packing efficiency will be very high. Okay, is that okay or not? Please keep in mind, these things are written here. Please read it. आगे बढ़ेंगे. Solubility. Haloarenes are insoluble in water because they cannot form hydrogen bonds with water, but are soluble in organic solvents. Organic solvents मतलब आप जनरली क्या ले लो, कार्बन डाइऑक्साइड ले लो, बेंजीन ले लो, या फिर these things you can just take, there it will be dissolved. Density, haloarenes are all heavier than water, and their densities follow the order. Iodo is more than bromo is more than chloro. Not a big deal, you understand it. Next topic is chemical properties of haloarenes. So we all know that the best topic, or you can say the most important one is what? Electrophilic substitution. But there they can also give nucleophilic substitution reaction in the drastic conditions. We'll talk about it. Next, आगे बढ़ेंगे like this. Among the following, the correct order of reactivity towards ARSN. Can you see ARSN? ARSN matlab it is not talking about the, it is electrophilic substitution nahi. It is asking for nucleophilic substitution reaction, or aromatic nucleophilic substitution reaction. Always remember, here intermediate. Here is carbon ion. If carbon ion is the intermediate, so एक ऐसा चीज, if something is there that can stabilize the carbon ion, it will be make the reaction faster. So nitro is having what? Minus M. It is also what? Minus M. What is this? This is minus M only from one side. It is what? Only minus I, because it is at meta, and it is going to do what? Minus M, as well as minus I. ये भी करेगा minus M, but here minus I will be weaker, here minus I will be stronger. So what we can say is सबसे strong कौन होने वाला है? I think strongest effect is 1. After that, what is going to be 4, and then 2. At last it will be 3. So it is basically about the rate. Rate is directly proportional to stability of कार्बेनाइन. तो कार्बेनाइन सबसे ज्यादा कहां पे स्टेबल बनेगा? क्योंकि होगा क्या, मान लो OH माइनस है, वो अटैक करेगा, Cl माइनस को हटाएगा, तो क्या बनता है यहाँ पे नेगेटिव। सो उस नेगेटिव को जो ज्यादा स्टेबिलाईज कर पाएगा, जो भी उस नेगेटिव को ज्यादा स्टेबिलाईज करेगा, दैट विल बी मोर स्टेबल. सो 1 is more than 4, 1 4 2 3, 1 is more than 4 is more than 2, 1 4 2 3. I think this option D is the correct option. Option D, just because of some issue it is coming here. Chlorobenzene reacts with magnesium in dry ether to give a compound A, which further reacts with ethanol to yield. देखो, always remember it is nothing but whenever there is going to be chlorobenzene, when it reacts with magnesium and dry ether, so what will happen, magnesium and dry ether, so this is the formation of, it is the reaction of formation of Grignard reagent. So Grignard reagent कैसे बनेगा, जरा खुद से सोचो. It will be here Mg, or we can say pH MgCl. So pH minus and MgCl plus. Now if there is RMgX, okay, if you make anything react with something that has the acidic hydrogen, does it have the acidic hydrogen? Yes, it is acidic hydrogen. तो जब भी कोई acidic hydrogen वाले species के साथ Grignard reagent reacts with, what will happen? This will be something like break like that, negative positive. Then pH minus को H plus के साथ add कर दो, pH H. अरे इसको तो हम लोग प्यार से क्या बोलते हैं, C6H6. That is nothing but benzene. तो क्या बनेगा मेन here, benzene. आगे बढ़े, चलो. For which of the following G above reaction will be fastest? अच्छा, अब यहाँ पर देखो, aqueous KOH है. अगर aqueous KOH है, there is Cl and there is Cl being replaced by OH. So it is what? ARSN. मतलब aromatic substitution reaction, not electrophilic substitution reaction. So nucleophilic substitution, aromatic nucleophilic substitution, like this. Here it was aromatic nucleophilic substitution. Here also it is asking for aromatic nucleophilic substitution. तो अब यहाँ पर क्या होना चाहिए? This should be something that can stabilize the negative charge. What can stabilize negative charge? minus M and minus I. तो देखो, माइनस M की बात करो, ये क्या करता है, प्लस M कर देगा, ये क्या करेगा, प्लस H, ये क्या करेगा, माइनस M, ये भी करेगा माइनस M, बट दिस विल बी लेस एंड दिस विल बी वेरी हाई. तो ऑप्शन सी इज द करेक्ट ऑप्शन. आगे बढ़ो. इन अबव रिएक्शन सीक्वेंस Z इज, देखो एक और बात यहां से याद रखना, फॉर ARSN reaction, keep few things in mind. कंसिडर करो कि there is Cl and there is NO2 at this place, or you can keep it like Cl NO2, di substituted. Let's say there is two place there is nitro, and if there is at three places there is nitro. Now try to make it react with OH minus. So all these reactions, because what is happening here, PH-Cl bond, here what is happening, can you see that Cl, chlorine and benzene, their lone pair is there in the resonance. So there is what, partial double bond character. Partial double bond character ko break karne mein it takes a lot of energy. So here you need to make it more stabilized for the whole reaction. तो अब यहाँ पर क्या है, so it takes energy. अब वो energy अब यहाँ पर क्या होगी, ज्यादा लगेगी, because there is less stabilization. यहाँ पे there is more stabilization, यहाँ पे there is even more stabilization. तो यहाँ पे energy सबसे कम लगेगी. तो यहाँ पर temperature how much we have to take? We have to take 150 degrees Celsius. But here how much? 95 degrees Celsius. Here how much? Just warm water is enough. Warm water is enough. Warm water is enough, and it will convert into, I hope you all can see, Cl will convert into OH, and here it will be NO2. So very important is this conditions, that this condition is more vigorous when there is nitro is less, or less vigorous when the nitro is more. I hope you all can do such kind of questions very easily. And what about this? If there is going to be OH, NO2 and NO2. Any doubt? I hope it is all very clear. देखो, there should be some questions from electrophilic substitution reaction also, but electrophilic substitution reaction has nothing very special. You all know that already. Last day we have studied many questions, done many questions on that basis. Now CH3Cl reacts with CH3CN. चलो भाई, तो first of all what it NaCN. Na plus Cn minus, can you see what will happen? NaCN, if it was, consider करो, अब यहाँ पर मैं तुम्हें दो चीजें बताता हूँ. If it was AgCN, what will be the formation? It will form CH3, CH2, NC. But because it is NaCN, so this will be formed cyanide. But here it was what? It would become isocyanide. So this will become CH3, CH2, CN. अब CH3, CH2 को क्या कर रहे हो? CN को क्या है? साइनाइड को जब भी आप रिड्यूस करते हो, CH3, CH2, C ट्रिपल बॉन्ड N, जब इसे निकिल इन द प्रेजेंस ऑफ हाइड्रोजन, अगर जब आप इसे रिड्यूस करोगे, इट विल व्हाट विल हैपन? इसे दो हाइड्रोजन दे दो, इसे दो हाइड्रोजन दे दो, डायरेक्टली कन्वर्ट इनटू CH3, CH2, CH2, NH2. इट कन्वर्ट्स इट इनटू अमीन, 1 डिग्री अमीन. 1 डिग्री अमीन को अगर तुमने CH3CO, CH3CO, CO, CH3, that is nothing but एसिटिक एनहाइड्राइड. एसिटिक एनहाइड्राइड से रिएक्शन कराया, सो व्हाट विल हैपन? कैन यू सी एसिटिक एनहाइड्राइड कौन सा रिएक्शन दे देते हैं भाई? आई होप यू ऑल नो दैट देयर इज CO. CO is there, so therefore there delta negative, there it is delta positive. So what will happen? There is, can you see, it is nothing but it is nucleophile. Can you see there carbon पे delta positive? What will happen? It will attack on this. Can you see it is nothing but PR? So this is nothing but PRNH2. It is nothing but PRNH2, and this nitrogen is attacking here. So what will be the whole intermediate will be looking like CH3, CH3, CO. अब ये देखो, जैसे इस पे अटैक होगा, this will be shifted toward oxygen, O minus, there will be NH2, NH, one more hydrogen H, और यहाँ पर आ जाओ भाई PR, and यहाँ पर क्या हो जाएगा? OCH3. What is there? The next thing, can you see there? How many of the bonds are there on nitrogen? There are 4 bonds are there. So nitrogen पे formal charge क्या आ जाएगा? +1. So because nitrogen is making one more bond than it can make, it generally makes 3, but it is making 4, so therefore 1 positive charge. What will happen? अब यहाँ पर NaNH2, क्या ये ऐसा थोड़ी ना है कि बस PRNH2 more, there is some more, what will happen? This NH2 will attack on this और इस हाइड्रोजन को निकाल ले जाएगा. While because there is nitrogen positive charge is not good when there is hydrogen. So this bond pair will be taken by nitrogen, and there will be nitrogen ka again how many bonds? 3 bonds. So can you see? It will be like CH3, CO minus, and here it is going to be NHPR, that is propyl, and the rest one is OCOMe. What will happen? This O minus will again migrate here back, and because it is a good leaving group, it will be leaving so easily, and ultimately जो आपका product बनेगा क्या बनेगा भाई? CH3, C double bond O, NHPR. Can you see? Is there anything like that? So PR, NH, PR is nothing but here PR, NH, CO, CH3. तो वही तो है ये ऑप्शन ए. ऑप्शन ए इज द करेक्ट ऑप्शन. कैन यू सी? देखो अब यहां से अब ये क्वेश्चन जो है अल्टीमेटली ये पूरा का पूरा यू हैव टू नो द बेसिक्स. आई एम जस्ट हियर, वी आर जस्ट रिवाइजिंग. So I hope whatever I am telling you, all these things are already, you know these things, okay? So even if I am using few things from amines, these things, not a big deal. Even though I am using few of the things from acid and acid derivatives, not an issue. Even if I am going to use from aldehyde ketones, not a big deal. I think you are there because NEET exam is just there on your heads, so you would be just aware about all these things, okay? चलो आगे बढ़ेंगे. So here the question. The carbon atom in which halogen is attached in the haloarene can be. यार haloarene पे attached carbon. Can you see? ये देखो, जरा ध्यान से देखो. Here Cl is there. So what about this carbon? Can you see this carbon? There is how many sigma? 1 sigma, 2 sigma, 3 sigma. Is there any lone pair? No. So what is that? It is sp2 hybridized. Not a big deal. हटाओ इसको. sp2 hybridized. sp2. आगे बढ़ो. Next, the CaCl bond in 1122 tetrachloroethane. Okay, so there is Cl and tetrachloromethane. Cl. What will be this angle? So it is asking for ClCCl. So can you see that this is nothing but sp3? For sp3, what is the bond angle? 109.5 degrees. I hope you all understand 109 degrees almost. What about this? Can you see it? This carbon, this is what? sp2 hybridized. If it is sp2 hybridized, so what will be this angle? 120 degrees. If it is 120 degrees, okay, so for first one it is going to be 120 degrees, but for this it is going to be 109.5. Okay, 109.5 degrees. Can you see any example here? Yes, of course. It is what? It is same only. 109.5 degrees is nothing but 109 degree 28 minutes. आगे बढ़ो. Phosgene gas is a common name for. Phosgene gas is common name for COCl2. COCl2. Okay. So carbonyl. Okay. Where is that? So, carbonyl chloride. COCl2. COCl2. Okay. Any doubt? How do we form it? देखो, जब CHCl3 है जो कि जिसे बोलते हो आप लोग क्या? Chloroform. Chloroform when it is, in the sunlight and when it is exposed to oxygen and sunlight, it converts into COCl2, a very poisonous gas. So please never ever use chloroform as anesthesia, because it may also, if you are exposing to sunlight and oxygen, it will be converting into phosgene and it may be very, very, very dangerous for that person, right? So just jokes apart, do not do that. Next, the molecular formula of the diphenyl methane. This diphenyl methane is this. How many structural isomers are possible when one of the hydrogen is replaced by a chlorine atom? Okay, now you have to see again. हमेशा ऐसे क्वेश्चन क्या करो? See how many types of hydrogen are there. If you see the type of hydrogen, remove those hydrogen. वहाँ पे Cl लगा दो. Means that many types of product will be formed. How many types of hydrogens are there? चलो check करो. Let's just check that. CH2. Okay. चलो आओ जरा ध्यान से देखो. How many of the types of hydrogen is there? Consider karo, it is nothing but A type, A type. Consider it is also HA, HA type, HA type. All these are same type. Okay. Can you see meta wala? HB type, HB type. Here also it is, because it is symmetrical. So it will also be HB, it will also be HB. Symmetrical है ना, तो ये भी HC, तो ये भी क्या हो गया? HC. How many types? 3 types अभी हो चुका है. Can you see this one? So this is what? D type. It is what? HD type. So how many types are there? 4 types of hydrogen are there. So therefore 4 products are there. So possible products are how many? 4 products will be there. Okay class. Okay everyone. So that was all from my side. I hope today's session will be very helpful for you for your revision. So I would expect that you will do even more more study with these things. There is a very important part that is called Grignard reagent in the same chapter, but I could not complete. I hope you all know that. The reason being that we have very much lack of time. Grignard reagent is very important topic. I would suggest you please study this. There is one more part. There is, you can open that NCERT. At last there is given polyhalogen compounds like DDT and those things are there. Please go through that. Questions may come from there, their industrial and all those things, importance. This is very important. Please go through it. So that was all from